Okay, so welcome to Module 2. Today we will look at the science in a different way, not just as facts and discoveries, but as something that changes how people think. So we will focus on Thomas Kuhn and his idea of scientific revolutions. So as you watch, there will be a few quick questions where I'll ask you to pause and then comment. So let's go. So Thomas Kuhn. So Thomas Kuhn didn't actually start as a historian. He was trained as a physicist and earned his degrees at Harvard. Later on, while teaching and studying older scientific texts, he became interested in how scientific ideas change over time. So, all throughout this lesson, or um, we we will not just be asking what science is, but how it affects people and how society also influences science. Okay, I would like you to pause the video and answer in the comment section this question. What was Thomas Kuhn's first field before he became known for studying the history of science? Okay, so Kuhn's background and interests. So Kuhn spent time studying Aristotle's works and realized that older scientists weren't simply wrong. They were working with a very different way of understanding the world. So this helped him see science as something shaped by its time. So around 1962, Kuhn published The Structure of Scientific Revolutions. So this book changed how people think about scientific progress. Instead of science slowly adding knowledge, Kuhn argued that science sometimes goes through big shifts. So for the traditional view, it says science grows step by step, but Kuhn disagreed. So he believed science stays stable for a while, then suddenly changes when old ideas no longer work. This time, I would like you to pause the video and answer in the comment section. According to Kuhn, does science usually change little by little, or does it change in big jumps when old ideas stop working? Write your answer in the comment section. Next, what is pre-science? So pre-science is the stage where there is no single accepted explanation yet. Scientists disagree and there are many competing ideas about how these things work. Next is the normal science. Once a dominant idea is accepted, scientists move into a normal science. Here, they don't question the main theory, instead, they focus on solving problems within it. So, after the normal science, we have the model drift. For the model drift and model revolution, over time, problems called anomalies appear. At first, scientists try to ignore or explain them away. When these problems pile up, a model revolution happens and new ideas challenge the old ones. We have the paradigm change, where it is when the scientific community accepts a new way of thinking. So this doesn't just change theories, It changes how scientists see the world and do their work. In example is the paradigm shift of heliocentric model. This is when people believe that Earth is the center of the solar system. So the heliocentric model replaced the belief of what I just mentioned about Earth as the center of the solar system. And this was a major shift in how people understood space and humanity's place in it. Next is the paradigm shift for germ theory. So, germ theory changed how people understood disease. So, instead of blaming bad air, scientists discovered that microorganisms cause illnesses. And of course, we also have the plate tectonics. So these showed that continents move. The big tectonic plate tectonics showed that continents move. So this idea helped explain earthquake, volcanoes, and mountains, things that were not poorly understood before. So right now, I would like you to pause and comment which of these paradigm shifts examples, which of these paradigm shifts examples surprise you the most and why? Just 1 to 2 sentences. Okay, thank you very much, and I'll see you again next time. Goodbye.